Consider the height and weight of 10 subjects given below. We seek to determine if there is a correlation between a person's height and weight, okay? If, as you change height, their weight changes in a specific way, okay? And so you have plotted this data. It looks something like this, yes? Okay. We want to create a scatter plot of the data. Does there appear to be a correlation between the height of a person and their weight? Yes. If so, is it positive or negative? And I'm saying positive. Why? Because the slope is up. As the x increases, so does the y. Okay? Now, that's true with ice cream cells and shark attacks. Okay? There is a correlation there. Does that mean ice cream cells cause shark attacks? No. Why would, as ice cream cells go up, shark attacks go up? Because it's summer and it's hotter, and so people are in the water. Well, you have to be in the water to be eaten by sharks, okay? So correlation does not always mean causation. There might be some other underlying variable making this happen. All right. Draw a line of best fit on the scatter plot. Pick any 2 points on your line and find the equation of the line. So you can pick my points or your own points, okay? But just do me a favor, sketch a line in the middle of this that you think goes through all the points. That one is mine. Does yours look the same? Is it off a little? Yeah. Okay, everybody, there are an infinite number of lines of best fit. The idea is to minimize the difference between the points and the lines. And we actually minimize squares formed, the area of the squares formed between the points and the lines, but we won't talk about that this semester. We'll talk about it next semester, okay? And I want you to find a line of best fit or a line of good fit. Well, how would you do that in secondary 1? You take 2 points, and what do you have to know to find a line? You need to know a point and how steep the line is. What's that called? The slope, okay? So you need the slope. Now I'm going to pick 2 points. I've picked this point and this point. They don't actually have to be data points, but I chose to use real data points. Okay, 71 and 163, and 66 and 126. I could have just said this point right here, 74 and maybe 190, as long as it's on my line that I draw in. So you can pick 2 of your own points, or you can use the points and make sure your line goes through it. I don't care. Okay, but if so, you need the slope of that line. Well, y minus y over x minus x, that gives you slope. The slope of my line is 7.4. Any questions how I did that? Right, because it won't let me rotate it sideways anymore so you can see it. Because this is an x value, y value, x value, y value. Okay. Now that I have a slope, you could use the y, you could use this formula, not my favorite. Oh, what is it? You guys remember this one? I don't like that one either. I prefer y equals mx plus b. So we're going to use y equals mx plus b to find an equation. Well, we know a point. Specifically, I'm going to say when x is 66 on my line, y is 126. So I'll plug that into the x and the y. And I now know my slope is 7.4. So I've plugged all those in and I can solve for b. If you did that, you would multiply 7.4 times 66 is 488.4. Bridger, write this down. Minus 488.4 from both sides, and you get a y-intercept of negative 36.3. negative 362.4. So that is your line of good fit. That is what I'm going to call my prediction equation. Is it the most accurate line that I could get? No, because I did it by hand. Okay? But it's okay. In the context of the problem, what does the slope represent? Somebody who has not answered today, what is this slope? That's not the slope. What does this 7.4 represent in the context of height and weight? Yeah. No, but good thought. The mean actually will show up on the perfect line of best fit. The average of the x's and the average of the y's. It is an average, which is an average of something else. Yeah. The average rate of growth. In particular, for every 1x, because we don't have it as a fraction, right? Slope is change of y over change of x. So when we would give you a fraction like this in a lower class, we'd say for every 3x, you would go up 4y. Well, when we give it to you like this, we're saying for every 1x, you go up 7.4y. Or, this is a Mad Lib sentence that you could memorize, you will next year or next semester. On average, so it is a type of average. By saying on average, you're saying based off of this prediction line, for every 1 inch in height, the weight increases by about 7.4 pounds. Is that exact? No, it's a prediction. Okay, sometimes people will go up 5 pounds. Sometimes maybe they've gone down 5 pounds because you're tall and lanky, okay, and skinny. But in general, the more of you there is, the more you weigh. Once you write that down, use your line of best fit to predict a person's weight who is 68 inches tall. I want you to plug in 68 into your equation and see how much you think they're going to weigh when you have it stand up. All right, so after you plug it in, you would predict that somebody that is 68 inches tall would weigh 140 pounds. That makes me feel bad. I'm working on it. All right. Okay. Okay, you guys good with that? So that is doing it what's called by eye. Everybody would be a little different. And you use algebra to get the best one you can. Okay? The next one I want to do is using the calculator. And hopefully we'll then have time to go back and do Excel. And then all you'll have to do is 1 for homework and turn all 4 in. Okay? So let's jump to this one. Number 3. A sample of, yes, sir. You will have to do 2 and 4. Hopefully I can do 1 more of those with you today on Excel, and then you only have to do 1 of them. I just can't remember which one that is. A sample of 7 households was obtained, and information on their income and food expenditures for the past month was collected. Okay? The data in hundreds of dollars are as followed. So, okay, hundreds of dollars. If their income is 22, ooh, I don't like that. Oh yeah, okay, it's just saying this is dollars. So if they make $2,200 a month, then they spend $700 on food. If you make $1,700 a month, this person spent $600 on food. Okay, we want to make a scatter plot. Well, we can do that by hand. So we will do it by hand. Go ahead and just sketch a quick one. You can copy mine. I feel like you could do that. You can even take a picture if you want, make it better later, I don't care. Just do a quick sketch. And then when you're done, can you put your data in list 1 and 2, just like we did in class the other day? But I want your X's in list 1 and your Y's in list 2. Your data should be in your calculator. Okay. And in order to do that, you're going to want to take some notes on this because you'll have to do another one by yourself later. You can stat edit. Now that you're there, we want to stat plot it on the calculator, and here's how you do it. Hit second, y equals. second y equals, and you want to turn your stat plot on, so hit enter. Okay, now you want it to be this thing right here, that's the scatter plot. So second y equals, stat plot on. You should take notes for this so you don't mess it up. You need a scatter plot. And then you want to do zoom 9. Sometimes you can do zoom 9 from here. I usually do second mode and quit out. I go and make sure there's nothing left over in my y equals from a different day. And then I go back out and hit zoom 9. And there's my scatter plot. Now what I want is the perfect line of best fit. Okay, the absolute perfect line of best fit. The one that would minimize the distance between all of these points in the line. Yes? So I'm going to review this again. You go into second y equals. Make sure your scatter plot is on. Hit the scatter. Your x's need to be wherever your x data was. So list 1. Your y's are in list 2. Once you do that, you can hit second quit and then zoom. Number 9 or whatever says zoom stat for you. All right, so now that we've done that, now we want to get the perfect line of best fit. So you may just have to follow along and write this down. Okay. We are going to do stat, push over to calculate, and then we're going to go to number 4, which is linear regression. Okay, our x data was in list 1, our y data was in list 2. You can stop right there if you want. I like to store my regression equation because it's going to give you a y equals mx plus b equation, and then you'd have to go back into y equals and type it in if you wanted to see it on the graph. Instead, I just wanted to put it there. So you can stop right here, or you can put your cursor right in front of store equation. Okay, and then you're going to go to vars for variables. That's right here, that red one. And y variables, push over to y variables. Function, because we're storing it as a function, and y1. And all that's doing right there is getting you a y1 right there. If you don't want to do that, that's fine. I also think I have a PDF on how to do that. I can put it on Canvas. Okay. You can also always Google, how do you do this stuff? You'll find a video. But if you do this now, hit calculate. That is my regression equation. Now I'll show you this on a piece. I'll have this written down for you in a minute, so just follow along. We also need the r and the r squared. So before I talk to you about that, hit graph. If you did this right and you stored your equation, there is my line of best fit. Okay? Then you have the wrong data in, or your window's off. So it should look like that. Okay? If you didn't do the store stuff at the bottom, you could just type in the equation right here, but this does it with all the variables. And one thing we're missing is we want to know what r and r squared is. So we need to turn in our diagnostics. So go to second 0, scroll down to D or hit D. There's another way to do this, but not all the calculators do it, so I'll teach you the long way. Scroll down to diagnostics on. Again, you're not going to be responsible for this on a test. This is a quick touch of linear regression. You were in class, I showed you, you did it. You'll do a problem at home and we'll call it good. Okay? I went second 0, hit the D button, and scrolled all the way down to where it says diagnostics on. You can also do it in mode, but not every operating system has it available in mode. So if you go to mode, it's your stats diagnostics. Now when you're in diagnostics on, hit enter, and then hit enter again until it says done. Now if it does that, if you were to run it again, stat, calculate, number 4, I'm going to hit calculate. Now it's going to give me more data. It's going to give me the slope, the y-intercept, an r-squared value, and an r value, which I'm just going to show for you. Okay, so this is what we have. It said our A was 0.2019, that's our slope. Our y-intercept was 186.9. So they're kind of saying with that y-intercept that if you didn't make any money, you'd still have to find out how to spend 187 bucks a month on food. If I put it in an equation then, now notice I put some subscripts here, you don't have to, but I'm saying my predicted food is given by this equation where I plug in my income. Now that you have this, this is what it's saying, okay? It's saying for every $1 you spend, or sorry, for every $1 increase in your income, you spend 0.20 more on food. That's what this is saying. And then your y-intercept again is saying if you didn't have an income, you'd still spend about $187 a month on food. This little hat here means it's a prediction equation. It's like pretending to be Y, so it's wearing a disguise, it's wearing a hat. So it's actually called Y hat. And then you have R and R squared. Does anybody remember what they are from secondary 1? And or maybe secondary 3? Yeah, that's fair. Okay, R is the amount of correlation. The closer this number is to 1 or -1, the better the points fit the line. So this is 0.92. If I look at it, if I were to draw this line in, okay, it's starting at 187. I'd want to be really accurate. I'd want to go to about 187 here, wherever that is, and draw it in. So if you draw one of these in at home, be really accurate. I just sketched mine. Okay. And it's saying that, look, those points really fit that line pretty well. Okay. Now, can you have a high R value and a non-good fit? Yes, but it's rare, and we can talk about that next semester. Okay. Squared is saying how much this change in X is affecting the change in Y. So I'm just going to give you these two sentences, okay, which are this. For R, we're going to say it's a strong, because it's really close to 1, and they look like they fit well. Positive, because the slope is positive. If R was negative, it would mean the slope was negative. Linear correlation between income and food expenditure. That makes sense. The more you have to spend, the more you might spend. Okay? And then R squared, this is kind of a Mad Lib. You could say based off of this equation, or something like on average. But approximately, notice this is 85.9% of the variation or variability in food expenditure of the change in your Y can be explained by the change or variation in your X. Okay, so maybe that other 14% is something else. How much you like to go out to eat, what type of food taste you have. But they claim that about 86% of it is directly related to how much money you have coming in. Is that exact? No. But that's what this model shows us. Approximately 85.9% of the variability in food expenditures can be explained by the variability in income. Okay. In the context of the problem, what does the slope represent then? It's that same Mad Lib, literally what we did before. On average, for every $1 increase in income, for every 1 increase in X, the food or the Y increases by about something. If your slope was negative, it would say decrease. Okay, if your slope was negative, it would decrease. So later, if I ask you to use these interpretations, you're just going to copy the sentence and change the amounts and the content. And then I'm sure you could do it because I made you do it last time. Use your line of best fit to predict the food expense for a family of 5,200. Okay, how much could they spend if they're bringing in 5,200 bucks a month? A lot more. Okay, they could spend 12,000 on food. That's some family's mortgage or rent. Plug it in and get a prediction amount. Okay, you will do number 2 all by yourself. It's already done the picture for you. Okay, you have to draw a line of best fit in by hand and pick any 2 points. You have to do it by hand like we did for number 1. Yep, do it by hand, just like number 1. So this is like number 1. Okay, and then at the very bottom, I'm going to add a D. Now use the calculator to find the exact one. So you'll have something like y hat equals blank x plus blank out of the calculator. So this is like number 3. Okay, as soon as you have this written down, now all of you don't have your computers out. That's a bummer. I should have made you do that.